You're looking at a dragon. A feathered dragon. It's intriguing to think of birds as descendants of dragons. Feathered dinosaurs. Among scientists, the dinosaur-bird link is the subject of a debate that is complex, diverse, contentious, and full of surprises. As one researcher said in a respected scientific journal, the dinosaur origin of birds will be the greatest embarrassment of paleontology in the 20th century. My name is Matt Lamanna, and I'm not embarrassed to say that I disagree with that statement. I'm a paleontologist at the Carnegie Museum of Natural History in Pittsburgh, Pennsylvania. I've studied dinosaurs all over the world, from Argentina to Egypt, and I am convinced that birds did have dinosaurian ancestors. How did birds evolve from toothed, scaly, long-tailed creatures into the amazing diversity of forms that we see today? And why did they alone survive today, when all other dinosaurs have long since perished? So, I'm about to embark on a journey, a trip I'll take with two of my friends and fellow paleontologists, Yu-Hai Liu and Jerry Harris. Together, we'll travel halfway around the world, to the edge of a remote Chinese desert, searching for evidence to solve a 65-million-year-old mystery. The enigma of the rise of the feathered dragons. Dinosaurs. I think they're some of the coolest creatures ever to walk the planet. People have been digging up dinosaurs for centuries, long before they understood what they were. In 1841, British zoologist Richard Owen coined the name Dinosauria, meaning terrible lizard. And for a long time, that's how we viewed dinosaurs, as tail-dragging, swamp-wallowing, overgrown lizards that we posed in museums like skeletal Godzillas. It was a humble throne for a dinosaur like the tyrant lizard king, T-Rex. And it wasn't accurate. Dinosaurs first appeared on Earth 230 million years ago, during the Triassic period. For the next 160 million years, they dominated practically every terrestrial niche available for an animal bigger than a chicken. Had it not been for some terrible events 65 million years ago, dinosaurs might still be in charge, roaming the planet and occasionally snacking on tiny and terrified mammals. While most dinosaur species did go extinct, one lineage has persisted. These dinosaurs are, in fact, the ultimate survivors. In 1802, 5 fossilized footprints stamped in a slab of brownstone were plowed up in a Connecticut valley by a boy named Pliny Moody. So strikingly did these tracks resemble those of a bird, they were thought to have been made by ancient poultry, or Noah's raven. It was not, however, until 34 years later that any attempt was made to describe these tracks scientifically. The man who did that was the Reverend Edward Hitchcock. Hitchcock was a brilliant paradox, a congregational minister and fervent anti-evolutionist. He was also one of the earliest, and perhaps the best minds in dinosaur science. Although he never used the term dinosaur, Hitchcock envisioned great flocks of giant terrestrial birds stomping the floodplains of a Jurassic landscape. He wasn't far from the truth. In early 2004, I was working at the Carnegie Museum of Natural History when I got a call from my friend and colleague Yu-Hai Liu.
We were talking about many things about birds or dinosaurs in China while we were studying together. And so after I came back to China in 2002, my advisor here, Professor Ji Qiang, provided me opportunity and support to work in Northwest China. And I also think I should invite some of my colleagues in the US to join me.
Ooh, that's a lot of stuff there.
Hailu, Jerry Harris, and I first met when we were all studying paleontology at the University of Pennsylvania in Philadelphia.
Disarticulated thoracic.
Jerry is now director of paleontology at Dixie State College in Utah. Jerry's a geologist, but he's also an incomparable anatomist with just a staggering, almost a bibliographic knowledge of dinosaurs and the world they lived in. Hailu works at the Chinese Academy of Geological Sciences in Beijing.
It's definitely a bone.
He's named 8 new dinosaur species and discovered many more.
Several hours.
Hailu's the key player on our team. Logistically, he's connected at every level. He knows the language, the customs, the people, and the terrain. Me, I'm a dinosaur guy. But a little of Hailu and Jerry has rubbed off on me. And now I'm every bit as interested in feathered dragons as they are.
Amazing.
Few places on Earth have been as prolific as China in contributing to our understanding of dinosaurs. In Mandarin, Kung Lung means both dragon and dinosaur. Here, in the Changma Basin of northwestern Gansu province, our expedition is looking for fossils of animals and plants that existed during the later part of the early Cretaceous period, around 110 million years ago. The early Cretaceous was a time when the Earth was still radically changing. It was also a time of tremendous evolutionary diversity. Birds, newly evolved from their dinosaurian precursors, were filling the skies, radiating into many different adaptive types. Then, suddenly, everything changed. Across the planet, a great dying marked the end of the Cretaceous period. One of the most puzzling things about the disappearance of non-avian dinosaurs is the selectivity of this extinction. Why did crocodiles, lizards, snakes, and mammals survive when every large dinosaur species went extinct? It's a question without an easy answer. However, it's difficult to piece together the evidence of these ancient extinctions and radiations. In the case of birds, it's even harder to speculate because the fossil record is so limited.
The first Chinese Mesozoic bird was found here in Changma. That was in the year of 1981.
The bird was named Gansus humanensis. The first specimen was just a left foot. Not much to go on. Even the best paleontologist can't tell much from a foot.
And then after 20 years, in September of 2002, our team worked here. We found the second Chinese Mesozoic bird in this park. Oh, great. You see? Here. What is this? It's a bird. It's a bird.
You see here? It's a claw, I think, yeah.
Gansus belongs to a group of birds called the Ornithuromorpha, the group that gave rise to modern birds. Ornithuromorph birds were just one of the many different families of birds that coexisted during the Mesozoic. The dominant land bird group of the age was the Enantiornithes, or opposite birds, so called because certain bones in their shoulders connect in the opposite way from those of modern birds. Although it's still a mystery why, we know opposite birds and other primitive birds died out at the end of the age of dinosaurs. They're side branches on the bird family tree, evolutionary dead ends. Though primitive compared to modern birds, Gansus was remarkably advanced for its time, more so than any other early Cretaceous bird. Its anatomy, especially its long, slender legs, suggests that it may have been an ancient counterpart of modern water birds, like ducks or grebes. Several of the fossils also preserve the carbonized residues of feathers and skin. One of the Gansus specimens even reveals webbing between its toes.
Our team have been working here since early July. So now is the end of October. We have been working here for almost 4 months. Yeah. So we are very excited. You can see that when the Mr. Pong, he found that, he said, yeah, this is my first time found a bird fossil here. Normally, it's not easy, very difficult actually to find a bird fossil So in the past 150 years, there are only less than 10 specimens of a Mesozoic bird fossil have been found. But here, we worked here only for about several months. We already found at least 20 specimens. Most of them are birds. So very, very exciting, very great discovery here.
The only part of Gansus we didn't find is its head, and consequently, we don't yet have a complete picture of what this bird looked like. Which leads us to a basic question. What is a bird? Most people would define birds as egg-laying, nest-building animals, with beaks and feathers, the ability to fly, most of them, and the uncanny knack for dumping on your windshield right after you've driven through the car wash. That's hardly the biological definition, and it omits any mention of animals that are warm-blooded, have hollow bones, fused tail vertebrae, or possess any of the myriad of other features that makes each and every one, well, uniquely a bird. Today, there are about 10,000 species of birds, more than any other living terrestrial vertebrate group in the world. Modern birds, a group we call Neornithes, come in all shapes and sizes. So what is a bird? The complete answer is complex and consists of a wide body of evidence, the evolutionary pieces of which have only been gathered over the last 150 years. In 1859, the first edition of Charles Darwin's groundbreaking work on the origin of species hit bookstores. Then, a little over a year later in 1861, some dramatic evidence to support his theory of evolution was discovered in a limestone quarry in Solnhofen, Germany. Meet Archaeopteryx, the first and most ancient bird from the age of dinosaurs ever found. It resembled the small dinosaur, but bore an unmistakable feature. It had feathers. It also had teeth, claws, a long tail, and a variety of other classically reptilian features. Arguably the most famous fossil ever found, Archaeopteryx blurred the distinction between birds and reptiles. But was it a true missing link? In the 1860s, Thomas Henry Huxley, mutton chops and all, championed another radical notion about the ancestry of birds. Examining the fossils of Archaeopteryx and another chicken-sized dinosaur, Compsognathus, Huxley was impressed with the stunning similarities in their bipedal posture, erect gait, and ankle joints. Because Compsognathus belonged to a group of meat-eating dinosaurs called the Theropoda, Huxley reasoned that birds and theropods must have been close relatives. Soon, the descent of birds from dinosaurs was being promoted by other prominent paleontologists, like Edward Drinker Cope and Othniel Charles Marsh. While Cope pronounced that Hitchcock's stony bird prints were made by dinosaurs, Marsh cataloged so many skeletal similarities between birds and certain small carnivorous dinosaurs that he suggested their difference was mainly one of feathers. Then, in 1926, a Danish illustrator and scientist named Gerhard Heilmann reversed the debate. Heilmann believed that birds could not be descended from dinosaurs, largely because dinosaurs lacked clavicles, or collarbones. Clavicles are the evolutionary forerunner of the furcula, or wishbone.
For a long time, the only animals that were known to have a wishbone were birds. Since that time, people have started discovering wishbones in many meat-eating dinosaurs. Tyrannosaurus had one, Allosaurus had one, even all the way down to the very earliest meat-eating dinosaurs like Coelophysis also have a wishbone.
Ironically, Heilmann considered small, predatory dinosaurs to be ideal ancestors of birds, except for this one detail. He concluded that dinosaurs and birds did share a common ancestor, much earlier in time, one that was neither a dinosaur nor a bird. Heilmann's study of birds was so compelling and his views so persuasive, it became the status quo for the next 4 decades. That changed in 1964, when a paleontologist named John Ostrom and a crew from Yale University discovered a new and very surprising kind of dinosaur. This one. Their find wasn't all that big, roughly the size of an ostrich. And like an ostrich, its skeleton was designed to make it fast and agile. Then there was that thing on its feet, the thing for which Ostrom named his new dinosaur. Deinonychus, meaning terrible claw. Ostrom saw Deinonychus as an active predator, a dinosaur that chased down and killed other dinosaurs. But Ostrom's most surprising contribution was in comparing Deinonychus to Archaeopteryx. Except for feathers, Ostrom argued, the two animals were virtually indistinguishable. Did the differences between dinosaurs and birds boil down, as Othniel Marsh had said, to mainly one of feathers? It was only 10 years ago when someone stumbled on the surprising answer. It's the summer of 2005. Hailu, Jerry, and I are back in China to resume our search for Gansis. But before we head to Chiang Mai, Hailu takes us on a little detour. The village of Sihatun is 7 hours from Beijing, and the pace of life here moves much slower than it does in the big city. As the weather changes, so do the roads. Driving in China is a challenge. Even with an official escort, you quickly learn who rules the roads. In 1995, a farmer named Li Yinfang dug up something interesting in a rural area of Liaoning province in northeastern China. He had found similar fossils here before, but this one was by far the most complete. Li could only guess what it was, so he bought a train ticket to Beijing and took one of the slabs to Dr. Ji Chang of the Chinese Academy of Geological Sciences.
The specimen I got is not the first specimen. That's the third specimen. That, in 1995, the first specimen was found, but the local farmer gave it to Nanjing Institute of Geology and Paleontology. They thought it's only a small theropod, that's all.
As he studied the fossil, Dr. G observed a curious feature: an odd, feather-like fuzz, what we now call protofeathers, on its body. All birds have feathers, but the animal G was staring at was clearly no bird. So he named it Sinosauropteryx, meaning Chinese lizard wing. It was the first feathered non-avian dinosaur ever discovered in China, and indeed, anywhere in the world. Only the world didn't know it yet. That would take another year, when another scientist from the Nanjing Institute, Dr. Chen Peizhi, attended the 56th annual meeting of the Society of Vertebrate Paleontology.
Now, if he'd attended the Society of Vertebrate Paleontology meeting that took place in Laramie, Wyoming, or in Bozeman, Montana, or in Norman, Oklahoma, it might not have had the same impact. But the 1996 meeting was held at the American Museum of Natural History in New York. So Chen Peizhi brought photographs of a small Chinese dinosaur with a fringe or frill of feather-like structures running down its back. And he just didn't bring the fossil, just brought photographs. He didn't give a paper, he just walked around showing scientists these photos, and the effect was electrifying.
Soon, Sinosauropteryx was making headlines. Over the next several years, Liaoning proved to be a treasure trove as more astounding discoveries were unearthed. Among them were Caudipteryx and Protarchaeopteryx, and Microraptor guii, a weird-looking creature with long feathers on both its arms and its legs. The Liaoning discoveries conclusively demonstrate that feathers occurred on many types of ancient animals, some of which were clearly incapable of flight. They also raise a compelling question. If some feathered dinosaurs couldn't fly, how and why did they evolve feathers in the first place? After all, who needs feathers?
And feathers develop in a very unique way. Initially, a lot of people thought that having scales were a logical progenitor to feathers, but it turns out that because scales develop so differently, bird feathers must have arisen as a completely unique structure. They didn't have any type of modern analog that you would look at and call a scale that preceded it.
Feathers are composed mostly of keratin, the same substance that hair, fingernails, horns, hooves, and beaks are made of. A typical feather has a hollow central shaft called a rachis, or quill. Extending from either side of this backbone are linear clusters of barbs. Branching out at a roughly 40-degree angle on each barb is a network of microscopic interlocking hooklets called barbules that provide both stiffness and flexibility to the feather. Taken together, these rows of barbs and barbules form the familiar vein of the feather. While birds display several different adaptive types of feathers, like down feathers and bristles, it's the aerodynamically shaped contour feathers on their wings and tail that make it possible for a bird to fly. However, even flightless birds have feathers, and shorebirds and waterfowl seem equally well adapted for life in water as they are for life in the air. All modern birds are endothermic, or warm-blooded animals, and their feathers help to insulate them in their environments. Feathers would have also helped small theropods retain body heat, which probably gave them an evolutionary advantage. Today, the feathered dinosaur quarries of Liaoning are world famous. To preserve the sites, the government is building a museum here. The hope is that someday it'll become a major tourist attraction. Inside, Hailu takes us to meet the man who started it all, Mr. Li Yinfang.
李云芳，给你介绍两个朋友。Jerry, so this is Mr. Li Yinfang who found the first feathered dinosaur.
An honor, sir.
Yeah, Jerry Li Yinfang. Matt, yeah, this is the man who found the first feathered dinosaur.
Nice to meet you.
他们都是美国的，一个是 Jerry， 一个叫
Hailu. Can you tell him he's a famous man in the United States?
OK， 他说你在美国很有名。
Tell him, see what he did?
The museum houses fossils from the early Cretaceous period, about 124 to 130 million years ago. Workers chip away at the layers of sediment and volcanic ash that buried the animals and plants in what was an ancient lake bed. The Chinese are meticulously preserving the geological context of each specimen.
Okay. So he said the first feathered dinosaur was found over there, but the layer, the horizon, is relatively
That one right there.
right here.
It's definitely a dorsal view, like a top view.
Yeah.
There's a 3D quality to the specimens. Fossil slabs are inset on the floor, in the exact spot where they were uncovered, giving you the impression that you are discovering them for the first time.
Down to this rather than breaking shells.
Yeah, they didn't,
you know what I mean?
split this.
Yeah, from top down.
Yeah.
So we can. Very cool.
This poor little guy was just.
Yeah, his whole face went.
Of particular interest to Jerry is the part of the quarry wall that has been preserved.
Like this are exceptionally unusual for geologists because most types of sedimentary rock, sediment is deposited just in episodes when there's a major flood on a river, for example, and those don't happen every day or every year on any regular basis. Whereas in lakes, such as this, sediment gets deposited at a very, very regular rate. So if you look at these rocks very closely, you can see very, very thin, paper-thin individual layers on here that are generally deposited on a yearly cycle. So each one of these very thin layers on here, you can peel back and read one year, and then the next year, and then the year before that, and the year before that as well, as you go up or down through the column.
125 million years ago, the skies over northern China were alive with primitive birds like this beautifully preserved Confucius ornis, a bird more advanced than Archaeopteryx, but more primitive than Gansus or opposite birds.
The rest of the body, you know, it seems like
The hands and the claws.
At least hundreds of these Confucius have been found.
Got the standard dinosaur skull, but it's no teeth and basically a bird body attached except for the hand.
And just the extremely well-developed claws are sort of a hallmark of the dinosaur ancestry of this bird.
One thing the Liaoning deposits do tell us with some precision is that feathered dinosaurs lived here 20 million years later than Archaeopteryx. However, there's still a gap of about 50 million years that separates the Liaoning assemblage from the first appearance of modern-type birds. Even in evolutionary time frames, that's a big jump. A lot can happen in 50 million years, and that's where Gansus fits in. After showing us around the museum, Mr. Li graciously invites us to his home for a midday meal. Because of his success as a fossil finder, Li has also become something of a local celebrity.
Impressive, like a beast. Dogs for security, Hailu? Because he has some things he should protect here, right? Yeah.
Birds.
Yeah.
Bird watcher.
Yeah.
As the bird dog stands guard outside, we sit down to a home-cooked feast.
Hailu, can you tell him, thank him for the food and tell him that this is very, very good food?
Excellent.
Only a fraction of the fossils at Liaoning have been excavated by professional paleontologists.
Thank you.
Most have been found by local people, like Mr. Lee.
What was it like when he first found what was ultimately going to become Sinosauropteryx? When he first saw the feathered dinosaur, what did he think?
回来以后才知道这个。回来以后咱也没看明白。当时呢，咱那块石板在中间板中间夹着。劈开以后啊，咱认为这块化石不完整的。拿那个杂志那个德国那个始祖鸟对比的话。
Liaoning has become world famous. While Lee's prosperity may have gone to our stomachs, it hasn't gone to his head. He remains a modest man and a delightful host. There's no doubt about it, flying looks magical. Besides birds, only two other groups of vertebrate animals, bats and prehistoric flying reptiles called pterosaurs, ever learned how to fly. But neither bats nor pterosaurs were feathered, so there's little about them that explains the origins of avian flight. There are two basic ideas that we scientists debate, or more accurately, argue about. One is called the ground-up hypothesis. The other is called the trees-down hypothesis. The trees-down idea is pretty obvious. The first flyers are seen as climbers who jumped from high places. Using their outstretched limbs adorned with proto-feathers, they learned to parachute, then glide, in order to slow their descent. Eventually, as their feathers evolved, adaptations for better climbing and gliding were co-opted for more refined arm and tail movements to achieve powered flight. The ground-up idea proposes that flight developed when small, agile theropods ran, hopped, and eventually leapt off the ground. The flapping of their feathered arms may have originated as an extension to the thrusting forearm motion they used to reach out and grab their prey. This stereotyped motion, reaching out, down and forward, and up and back, essentially, that's the flight stroke.
The features that enable a bird to flap its arms in that fashion have an obvious adaptation other than flight. A lot of the dinosaurs that have been found, for example, at Liaoning, that are hypothesized to have been arboreal, have the ability to get their arms way out to the sides, and they have very large claws on their hands. They're using that possibly to grasp a hold of trunks, so they're not just using their feet, they're not continually having to flap to keep themselves there. Anybody who's chased a lizard up a tree has seen them do something relatively similar along those lines. And just because we don't see anything doing that today doesn't mean that things in the past weren't doing that exact same thing. So I don't know that it's necessarily as clear-cut as ground up or trees down anymore.
It's 2,000 kilometers from Liaoning to Chiang Mai. To get there, we fly to Dunhuang in Gansu province. The name Dunhuang means prospering or flourishing. It's an oasis that stands at a crucial junction along the ancient braid of caravan trails known as the Silk Road. In many ways, things haven't changed much since Marco Polo passed this way over 700 years ago. The wind blows in from the west, spirals up, and flows out through the eastern passes. We're heading into a desert. The Chiang Mai site is just up ahead, but as we round the bend, we run into something unexpected. A funeral procession. We suddenly feel like intruders. Perhaps the same remoteness of this barren landscape that makes finding fossils possible has also led the people to use the area as a peaceful graveyard. The Chiang Mai Basin sits in the shadow of the snow-capped Chilian Mountains on the northernmost edge of the Tibetan Plateau. It's rugged country, with active faults running through the valley. It's taken 6 hours of continuous driving on bumpy roads to reach the site, and I, for one, am very happy to finally be here.
Okay.
你好，小梁。辛苦辛苦。
It's amazing how much work has been done at the site since last year.
It's unbelievable. It wasn't even a.
Yeah, last year we just have this
little
small
bit.
quarry here. Yeah.
And this is, I don't know, 10 times the size, maybe?
At least 10 times.
Yeah.
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 Yeah. Right above this.
That's it?
Yeah.
That's where all of last year's birds came from?
Yes.
Really?
Yes.
So-
And this is all new?
Yes.
From this year?
So if this is
Yeah.
10 times as big, we should have 10 times as many birds.
Right. Yeah. That's unbelievable.
While I appreciate Jerry's optimism, the chances of finding the exact fossils we're looking for are extremely small.
What do you think? Skull shaped?
Egg. Egg shape. We were joking about that. Egg shape.
Working the beds at Chiang Mai is different than working at Liaoning. Here, the beds have been tilted, so they're very close to vertical. That's a function of mountain building in this vicinity.
Well, this area is probably very seismically active, like it is now.
Although we know these fossil-bearing rocks were deposited during the early Cretaceous period, that's a huge chunk of time. One of our goals is to better pinpoint the geologic age of the fossils we found at Chiang Mai. It might not look like it now, but 110 million years ago, this was the bottom of a lake.
Well, this, as a lake basin, was a source where gravity is pulling all water and all sediment and all material downhill into it. And this includes dead organisms and parts of their bodies, for plants and animals and such. And so anything that gets washed out into the basin is going to float out a ways, and once it decays enough, its body will sink down to the bottom, and it will slowly get covered with small grains of mud. And a great example of it, you can see that's exposed right here in the side of this outcrop. So what you're looking at here is a little stem from the end of a conifer branch. It's got a little main branch with little side branches and little leaflets hanging off of it. So this was the tip of a branch on a tree that was growing somewhere near the shore of this ancient lake and fell off and was blown into the river or washed in by stream water or something, floated out to this point, however far we are from the ancient shoreline, settled to the bottom in this spot, got covered with mud, and over millions of years was compressed a little bit, which is why it's flat now instead of three-dimensional, and preserved, and as soon as these layers were split open, there it is, waiting for us to find it.
These fine-grained lacustrine, or lake sediments, accumulate in layers as thin as a sheet of paper. They not only preserve robust skeletal parts of organisms, but even more delicate traces. Sometimes, their presence creates a zone of weakness in the slabs that causes them to split where the fossils are. It's like opening a book.
Oh, we have a feather here. Matt?
Oh yeah?
Jerry? Have a look.
Oh yeah, definitely.
Oh
A feather?
Yeah, a down feather.
Yeah,
So
this one is very well preserved.
Yeah.
Oh yeah,
very
definitely.
detailed here,
Yeah, definitely. But that's the cool thing about that people have found feathered dinosaurs is that when we find a feather, we're not totally sure if it came from a bird or a dinosaur anymore.
Yeah, okay, so now we have feather, so
Some feathered creature may be inside.
here, right here. Yeah.
Well, if you find
One of the workers has just uncovered what appears to be a leg and foot of Gansus.
It's supremely cool.
So, just a few minutes ago, I told Jerry and Hailu that if we found a bird today, that I would eat a duck foot. So I guess I have to eat a duck foot.
Sometime.
So far, we've uncovered an abundance of spectacular fossils pertaining to a broad diversity of life that existed here over 100 million years ago, including insects, crustaceans, fishes, amphibians, and dinosaurs.
And there's an insect that Jerry found.
the upside down beetle.
By studying these specimens, our hope is that Chiang Mai may someday be as important as Liaoning and yielding the clearest picture yet of the early evolution and diversification of modern birds. Not bad for the end of a long day's work. We're fortunate that the Chiang Mai site is quite close to town. We've rented a local farmhouse where we keep the fossils before shipping them back to Beijing. After a long day of digging, it feels good to sit down.
This should be a lot of fun.
Relax.
Yeah. Have a beer.
Yeah.
Tomorrow, we head back to Beijing. But for now...
I've been waiting for the beer all day.
Right.
Ah,
先让他拍一张啊，
cheers.
完了我们先让他拍一拍这个啊。
Cheers.
Okay, cheers.
Yeah.
Cheers.
Great day.
Okay.
Very successful.
After dinner, Leon serves up a special dessert. Some of the fossils that were found earlier in the season.
Ooh, that one's humorous.
Look at the feathers on that one.
It's an interesting anomaly that most of the birds that they've found at Liaoning are Confucius ornithids and enantiornithians, birds that vanished at the end of the age of dinosaurs. But at Chiang Mai, the situation is reversed.
Oh, nice, 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 nice. It's got a whole pelvis.
Here, we've found few opposite birds and no Confucius ornithids, but instead an abundance of ornithuromorphs, the group that includes the oldest ancestors of modern birds.
That's going to be a nice one.
Our excitement over these fossils soon draws a crowd. Kids love fossils, especially dinosaurs, and that's important.
Hallie, were you telling them to look for the feathers?
Yeah.
Often, a young person's first introduction to science is through dinosaurs. They're great teaching tools. You can learn geography with dinosaurs. You can learn numbers with dinosaurs. You can learn big time from dinosaurs. As our group of future scientists watches, Jerry displays yet another of his hidden talents. The expressions on these kids' faces show that it's possible to learn something from a paper dragon too.
像不像个鸟啊？可以动吧？看看会不会飞？
After our fieldwork in Chiang Mai, returning to Beijing is culture shock. Jerry and I make our way across the city to meet up with Hailu at his office.
Here it is.
We're back.
Our good friend Peter Dodson is here too.
Yeah, great show. Pleasure to work on.
Oh, busy, busy, busy.
Hailu, Jerry, and I studied under Peter at the University of Pennsylvania. He's a mentor and brings a wealth of knowledge and insights to the analysis of the specimens we've brought back from Chiang Mai.
Dorsal viewers.
During the several months field season, we found dozens of fossil birds. All the specimens we found were sent here in my office. So my technician, Mr. Zhang, prepared all these specimens during the last year. And at least 30 bird specimens are ready for our study now.
Although the fossil evidence relating to the early phases of avian evolution has dramatically increased during the last few years, the life habits of primitive birds are still poorly understood. So, what do we hope to learn from our small, still headless Gansus? From our studies, we know that Gansus, coupled with a few other fossil bird species, provides strong evidence that the origins of the Neornithes, the group that includes all modern birds, may have occurred in aquatic niches. The niches of terrestrial, perching birds were virtually all occupied by opposite birds, all of which went extinct at the end of the Cretaceous. In other words, unlike nearly all other early Cretaceous birds, Gansus is a close relative of modern birds, and its aquatic nature suggests that the earliest ancestors of modern birds may have been aquatic too. If this is true, Gansus may help resolve the mystery of why one and only one group of birds survived a mass extinction when all other dinosaur species did not. 65 million years ago, a massive asteroid or comet struck the Earth at a place called Chicxulub on the Yucatan Peninsula in Mexico. The energy released by this impact was equal to 100 million megatons of TNT, 6 million times more energetic than the 1980 Mount St. Helens volcanic eruption. It's theorized that at ground zero, billions of things were instantly vaporized as a superheated thermal pulse radiated from the impact site, a fireball that ignited the planet. Even life distant enough to survive the initial incineration could have been asphyxiated by poison gases, entombed by debris, or engulfed by massive tsunamis. Vast clouds of dust and ash ejected from the crater circled the globe, blocking out sunlight, and making it too dark for photosynthesis to occur for perhaps a year. The residue from rocks pulverized by the blast mixed with water in the atmosphere, producing sulfuric acid, which later fell back to Earth as acid rain. This caused widespread defoliation on land and decimated aquatic vegetation in shallow lakes and seas. This cataclysmic disruption in the food chain caused entire species to starve to death. It may have been that species that were aquatic or semi-aquatic in habit were better shielded from the effects of the heat pulse and its aftermath. If early members of the Neornithes were aquatic, as their fossil record suggests, then their aquatic nature may have allowed them to survive extinction, while other, more terrestrial birds did not. It may have been water, or the adaptation to it, that saved these dinosaurs from perishing. Unfortunately for me, the time has come to pay off on my bet to eat a duck's foot. Hailu takes us to one of his favorite restaurants.
Oh, this is a Peking duck restaurant.
Oh, nice.
Man! You see the ducks?
Feet off for you.
Yeah. So if they don't have any feet, does that mean I don't have to eat any?
They can try to order another one from other restaurant.
Yeah, okay, maybe never.
Maybe try, so who knows?
We can stop by McDuck's feet for dessert.
Get a duck foot shake.
All right, let's get this over with.
All right.
Okay.
It's taken a lot to support our work at Chiang Mai. And I'm glad that Dr. Jie-Shi Lo and Alan Tabram are here to help us celebrate.
Sure.
Lo is my boss at the Carnegie Museum and one of the most accomplished vertebrate paleontologists in the world. Alan is a scientific preparator at the museum and a fine paleontologist in his own right. My friends recognize my obvious anxiety. To calm my nerves, the conversation turns to naming dinosaurs.
The best of all examples is actually Tyrannosaurus Rex.
That's a very evocative name.
About his dinosaur's name?
No.
Peter and I named it a sauropod, Su'uwasia, which comes from the Crow Native American roots, Su'u and Wasa, which mean ancient thunder.
My favorite dinosaur name of all time, and Peter may know this already, is Laelaps aquilunguus, eagle-clawed stormwind.
Oh, yes.
Especially when I was younger and listening to a lot of heavy metal. You know, that was the kind of name that I always wanted to produce. So.
What's your least favorite?
Sacrificing my taste buds seems a small price to pay for the Ganse's foot and the wealth of other specimens that we've retrieved from our expeditions at Chiang Mai.
Eat the whole thing.
Yum.
But you won't regret it.
It's actually kind of good.
I fear we're both in for a whopper of a hangover tomorrow. I may take some powdered dragon bone for a cure. Dragon bones and dragon teeth are traditional ingredients in Chinese medicine. They use them to restore the internal balance of yin and yang. I may give it a try, if I survive. Survival and adaptation may be two of the most important lessons that I've learned as a paleontologist. The discovery that birds are a kind of dinosaur has revolutionized our notions of what a reptile is and what a dinosaur is. It's forced us to re-evaluate our vocabulary and change or adapt our way of thinking of what those words portray. What the evidence from Chiang Mai does is help sharpen our picture of how the ancestors of modern birds survived in a world once teeming with other, now extinct kinds of birds. Undoubtedly, they competed for some of the same resources. Ironically, the ecological niches that Ganses seems to have been relegated to may have serendipitously helped its descendants to survive extinction when all other dinosaurs who couldn't adapt ceased to exist. It's also sobering and humbling to think that Hailu, Jerry, and I are treading in the footsteps of Huxley, Heilman, Ostrom, Ji Chang, and Li Yunfang. If we can adapt and survive as scientists, and as human beings, who knows what lessons and secrets Chiang Mai has yet to reveal.